There's one number on the stats of your graphics card that matters more than everything else combined for local AI agents. And it's not the one you think. Most people build their AI computer the same way they would build the gaming PC. Faster processor, bigger graphics card, just more power. That's exactly why their setup runs like a garbage. In my previous business, I used to overcharge people for this stuff. It made me just sick of it, so I had to quit. Now I just show you how to build it yourself for completely free. Let me explain this in the simplest way I can. We're going to stay in one analogy for most of this video, so stick with me. Your local AI setup is like a restaurant kitchen. The graphics card, that's the part of your computer that does all the heavy math. Think of it as the chef. How fast the chef's hands move, how quickly they can chop, stir, plate. But the memory on the graphics card, called VRAM, that's the size of the kitchen counter, remember that. And here's the thing nobody's really talking about. The counter size matters more than hand speed. Here's what actually happens when you run AI locally. The AI model is basically a giant recipe. When you see a model labeled 7B, that means 7 billion. A 7 with 9 zeros after it. That's 7 billion tiny instructions that tell the AI how to think. More instructions, smarter AI. But also a bigger recipe that takes up more and more counter space. That entire recipe needs to sit on the counter while the chef works. If it fits, the chef works at full speed. Chopping, plating, no wasted movement at all. But the second the recipe is just too big for the counter, the chef has to keep running to the back storage room to grab ingredients. That storage room is your computer's regular memory. We call it RAM instead of VRAM. And it is just way much slower. We're talking about going from a smooth 40 words per second down to maybe 2 to 3 words, which is just unusable. Now, you might be wondering, how do people fit these massive recipes on a normal counter? They use shorthand. Instead of writing every instruction in full, detailed handwriting, they compress it down. We call it a 4-bit compression, which is the same recipe, just in a smaller notebook. You lose maybe a tiny bit of a detail, but it fits on way less counter space. At 4-bit compression, here's a cheat sheet for you. A 7 billion instruction model takes about 5 gigs of counter space. At 14 billion takes about 10, 32 billion takes about 20, 70 billion takes about 40. That's just the recipe sitting there. The chef hasn't even started cooking yet. The moment you start a conversation, the conversation memory starts growing, right? So think of it like 30 dishes piling up on the counter while the chef cooks. Longer conversation. There's obviously more dishes piling up, less room for the recipe. That's why a model that loads perfectly fine can still slow to a crawl. 20 minutes into a conversation, the counter ran out of that space. So the question here isn't how fast is my chef? The real question is supposed to be like, how big is my counter, the VRAM? That one number, VRAM, dictates almost everything about your local AI experience. Okay, so now you know the real bottleneck, but here's where most people still mess up. They pick the right counter and then just cheap out. They decided to cheap out on everything else in the kitchen. Or they just overbuy because some random Reddit post told them they need a $5,000 setup. Neither is true. Let me walk you through exactly what to buy at every budget level. So this is where most people should start, and it's way more affordable than you may have thought. The core of this build is just one graphics card, the RTX 4060 Ti with 16 gigs of VRAM, 16 gigs of counter space. Not the 8 gigs version, that's the wrong version, that's the trap. 8 gigs one fills up the second you load a real model plus the conversation. It's just the haywire, right? So this just start piling up immediately. You need at least 12 or 16. 12 or 16. I'm running mine on, I think mine is 16, yes. Around that, you build a simple desktop. A Ryzen 5 processor, that's the brain of the computer. For local AI, it matters way less than you think. But you still need a decent one though. 64 gigs of system RAM, that's the back storage room. You want it big enough that if things spill off the counter, there's somewhere for them to go, you know? Now a 2 terabyte SSD, that's your, think of it like a pantry, where all your model recipes are stored before you pull them onto the counter. Now, there should be a decent power supply as well. That's the electrical panel for the whole kitchen, and a case with a good airflow to keep it cool. So total cost, total damage is about $1,200 to $1,500. Obviously that's USD though. What does this actually run? It could run 7 and 8 billion instructions model very comfortably. That's your Qwen 3 8 billion parameters model that I covered in the last video. You may have watched it. So your DeepSeek Distill 7 billion, your Llama 8 billion, these are not toys. These models handle real coding assistant, document summaries, private chat, and very light agent workflows as well. You can push a 14 billion instructions model on this build as well, but you'll feel some kind of trade-off. So shorter conversation before the dishes pile up, maybe a slower output. It's still usable, but you're like bumping against the edge of the counter, the end of it, right? Now, if you're already in the Apple world, deep into the ecosystem, a MacBook Pro or Mac Mini with 16 gigs of unified memory gets you into the same exact tier. Here's why Apple is a little different from PC. On a regular PC, the graphics card has its own counter, and the computer has a separate storage room in the back room. But on a Mac, there's no storage room. It's just all one big freaking counter. The graphics and the main computer share the same pool of memory. That's what unified means. So 16 gigs on a Mac is all usable counter space. But there's a trade-off. Macs at this level are a little bit slower on raw speed compared to the dedicated NVIDIA graphics card. But you know, simplicity is just too difficult to beat. Ollama, one download, and just you're running models in minutes. This is the sweet spot for anyone doing serious local work, coding agents, document analysis, multi-step AI workflows. There are two paths here, I think. So path one, you can grab an RTX 4070 Ti Super with 16 gigs of counter space, which is much faster chef hands than the 4060 Ti, more headroom, better for agent style loops where the model is thinking properly, executing, and kind of thinking again. And there's other paths, which I think this is the move a lot of experienced local AI power user people make. You can buy a used RTX 3090. Wait for it. It's an older card, obviously, but like I told you, when it comes to local AI, the graphics card doesn't really matter. It's all VRAM. It's all VRAM. So it has 24 gigs of VRAM in this older graphics card. So 24 gigs of counter space is just a freaking different world. At 24, you can run 32 billion instructions model in shorthand and still have room left over for a long conversation. So models like Qwen 3 32B or DeepSeek R1 Distill 32B, and there are new models. I haven't tested those yet, but these are the models that start rivaling cloud quality for most everyday use cases. Rest of the build stays kind of similar, you know, Ryzen 7 processors, 64 gigs of RAM, 2 terabytes SSD, bigger the better. But you know, on the Mac side though, a Mac Mini M4 Pro with 64 gigs of unified memory lends you here too. That big share counter means you can load a 32 billion instructions model and still have breathing room for it. Speed is slower than the NVIDIA cards, but how slow are we talking? About like a 10 to 11, 12 words per second. We call it tokens per second is the official term. And it basically means how many words the AI spits out each second. You know, like when you type it in the GPT and it generates the output, the speed of the outputs being generated, that's tokens per second. And usually 10 to 15 feels like a person typing very fast. 30 plus feels like very instant. So 11 to 12 is you're at a comfortable range. Not blazing fast, but you know, comfortable. And the Mac runs quietly, sips power, and just works smooth like butter. Now, on to the next one. This is only worth it if your workflow genuinely demands it. Don't buy this because it sounds cool. You gotta take this seriously. The centerpiece is RTX 4090 with 24 gigs of counter space, paired with a Ryzen 9 processor, 128 gigs of system RAM, which is a massive storage room for overflow, right? And a beefy power supply. This runs 32 billion instructions models like butter. Just fast chef, big counter, long conversations, just complex Asian chains. You can probably also experiment with 70 billion instructions model at heavy compression, but something that I haven't done it by myself, so I can't really tell you like if it's actually vulnerable, right? So, but I heard it's working, but it's likely you're covering the entire counter with recipe pages. You can expect trade-offs on conversation lengths because there's just barely room for the dishes. Now the Apple equivalent is the Mac Studio with an M3 Ultra chip and 96 gigs of unified memory, 96 gigs of counter. This thing loads multiple recipes at once. A reasoning model, an embedding model, a coding model, all sitting on the counters simultaneously, and it idles at under 100 watts. The 4090 desktop will draw 5 to 10 times that underload. One more thing, you'll see people talking about RTX 1590 builds with 32 gigs of VRAM and dual GPU setups pushing 64 gigs total. That stuff exists, but we're talking like 10K setup, 10K plus. So that's like, I say that's the highest end of consumer grade graphics card, the boss level. This is for like people who actually want to train their own AI model to do something with it. Like, I don't know if you guys have seen a recent PewDiePie video where he trained his own AI models for 6+ months to cross the, I forgot the name of the benchmarks, but he did, which was pretty interesting. Anyway, quick note on a Raspberry Pi. I love the Pi. I don't use it anymore, but I made videos about it in the past, but it's not a local AI daily driver. A Pi 5 is great for like edge experiments, like running OpenClaw for sandbox agent execution, computer vision projects. But if you're trying to run a real language, large language model for chat or coding, you need one of the 3 tiers that I mentioned above instead of the Raspberry Pi. The Pi is the garage workshop for small projects, but the tiers above are for the actual kitchen. If hardware is half the equation, here's the software side. And I'm gonna keep this very tight. So for getting models running, 2 options dominate right now. Ollama, this is one that I use. It's a command line tool, so it's a little high learning curve, but it's that simple. You type one command, the model downloads and loads onto your computer, and it's just running there. Works on Mac, Windows, and Linux. You can also download it off of their website. LM Studio, which is the next one, the same idea but with a visual interface. What I mean by visual interface is like a ChatGPT, there's a chat window there. So if the command line interface kind of make you nervous, you can start here, LM Studio. Both of these handle model downloading, graphics card detection, and serving the model locally so your other tools can talk to it. But as far as I remember, these two have different size of context window. Now, here's a detail that'll save you real frustration here. Model files comes in different packaging formats. Think of it like how the same movie can be a DVD or, if you know, Blu-ray, same content, different packaging, optimized for just different players. There's GGUF, it's GUF. It's the format that plays best on Macs. So AWQ is the one built for NVIDIA graphics card. If you're on a Mac, just grab GGUF. If you're on Windows with an NVIDIA card, you can look into AWQ. Because what I heard that there was a test that showed that it gave the faster response time and better quality output compared to GGUF on the same card. So most people don't know this. They just grab whatever model files has the most downloads, and if they're using the wrong format for their machine, they're kind of leaving speed on the table there. So for agent workflows, you can plug Ollama into tools like N8N for automation, Crew AI for multi-agent setup, or build custom pipelines. But that's a whole separate video I'll cover later. I want to be straight with you because I think most AI content online isn't. Local AI agent is not a replacement for cloud AI, closed frontier models. I'm talking about ChatGPT, Claude, Gemini, just not yet. Maybe not even, not ever for everything. You know, the biggest, most powerful reasoning models that still live in the cloud. They're all US made. When I need frontier level thinking on a complex problem, I use Claude or GPT. Just that's the truth. But I now have a very high expectation of a new DeepSeek 4 coming. I don't know when, but hopefully it doesn't crash the stock market this time. Anyway, here's what local does better than anything in the cloud. It's just the privacy side, right? Your data never leaves your machine. No terms of service, no training on your prompts, no training on your secrets, your private life. No API logs, cost control, no surprise bills, which is very important. No token meters running. You just pay once for the hardware and every conversation after that is just free. Uptime, maybe your internet goes down, your local model does not care. It just keeps working. That's how it works. It just lives in your device once downloaded. Think of it like this. Local AI is your home gym, and cloud AI is like a commercial gym in downtown. Your home gym can handle maybe 80% of your workflows. It's always open, always private. You never wait for a machine. But once in a while, you need the heavy equipment downtime. You might want to do some deadlifts. That's fine. You use both. The smartest setup in 2026 and probably beyond is just a hybrid. Local for the daily work, cloud for the heavy lifting, and the builds I just showed you are exactly where that local size starts. So I know you love summary, so here's the summary. Buy the counter space, not hand speed. VRAM is the number that you need to focus on. Everything else is just secondary. Budget the whole kitchen, not just the chef. If you're new, you can start at tier 1, $1,200 to $1,500 builds. It's real, it's capable, and you can always upgrade the graphics card later. Too easy, right? So if this helped you figure out your build, why don't you drop a comment with a tier that you're going for? I read every single comment. And if you want the full part with links inside of it, I'll pin it in the comments. Thanks for watching. Bye now.